All right, here we go, guys. I'm going to go ahead and get started. I know that she's not here yet, but she will be in a little bit. So, this is called a polar grid. Don't freak out. What we've been doing all this time is a rectangular grid, sometimes called Cartesian coordinate plane. Relax. It's the same in a Cartesian. I guess let's talk about the difference between a polar. First, let's just graph polar right off the bat. So I'm going to pick some points. I'm going to write A, B, C, D. I'm picking 4 different points. I'm going to say A is 3 comma pi over 6. I'm going to say B is 4 comma pi over 4. I'm going to say C is 5 comma negative pi over 6. And I'm going to say D is negative 3 comma pi over 4. Okay. In a polar grid, in polar, an ordered pair is r comma theta. Similar to in Cartesian you would have done x comma y. So an ordered pair is r comma theta, where r stands for, guess what do you think it stands for? Radius. And theta is an angle. It could be in radian or degree, but we're going to do it in radian. You okay? All right. Are you following along? Okay, you're good. Do you remember this? I don't know if we did it with you guys. I think we did, right? Okay. So here it is. So letter A. What you do first. Okay. I know that when you're doing rectangular grid, you always do the x first and then the y. With polar, do the angle first because it makes life easier, and then do the r. So Chavez, what are you saying? Well, pi over 6 is this angle right here. See, that's pi over 6, that line. And then you're going to do the r. The r stands for radius, and it's always from the origin. So you're going to go to pi over 6, and then the radius, you're going to count to 3. 1, 2, 3. Boom. Those circles are going up by 1 unit. So this first circle is r equals 1, r equals 2, r equals 3, and so forth. Does that make sense? So there it is. Sometimes they show it like this, guys, to show the radius. That radius is 3, and that angle right there is pi over 6. But nonetheless, this coordinate right there is coordinate A, so I'm going to put A on it. Does that make sense how we did it? All right, letter B, 4 comma pi over 4. That's a 4. So I go to pi over 4 and I count to 4. 1, 2, 3, 4, point. And I put a B. And there it is. That's 4 comma pi over 4. Negative pi over 6. Well, negative pi over 6 would have been in quadrant 4. I know it doesn't say it, but this is that angle there. That's negative pi over 6. See? So you go to negative pi over 6, and then I'm going to plot 5. 1, 2, 3, 4, 5. Boom, point. That is letter C. That's negative pi over 6 comma 5. Are we okay so far? Okay. Pi over 4 comma negative 3. All right, do the angle first. Pi over 4, it's this one right here in quadrant 1. But that negative 3 means it goes in reverse. So you're going to be in quadrant 3. Does that make sense? So I'm going to go in reverse. So I'm going to go 1, 2, 3. 1, 2, 3. Boom, point. There it is. So that is letter D. So are we okay with graphing polar? All right. What makes rectangular and polar, like what are the connections between rectangular and quarter? So I'm going to exaggerate quadrant 1. I'm going to pick up random points, and I'm going to call that some x, some y. Okay, well, if we're doing it in polar, the distance from the origin to that point, that's r. And notice that I can draw a reference triangle here. Reference triangle. So this is my right angle. So the horizontal displacement has to be x, and that vertical displacement has to be a y. So what relationships do we see here? Well, I see that with Pythagorean theorem, x squared plus y squared equals r squared. If we call this an angle theta, see, so we can represent this as r comma theta. We can say that angle is, you can say theta is arctan of y over x, and I'm going to put check quadrant. Check quadrant. See? And let's see, what else? SOHCAHTOA. You can say that sine of this angle is opposite, which is y, over hypotenuse, which is r. So if I multiply both sides by r, you get this expression. I'm going to write y first, guys, because that's what it is. Y equals r sine theta. If I use the same deal with cosine theta equals adjacent over hypotenuse, x over r, then we can say that x is r cosine theta. And there it is, guys, my 4 formulas that make them unique to polar. Well, really, it's this one. Child, why are we learning polar? Why couldn't we just stick with rectangular? Well, guys, if you think about it, our world, or Earth, is it's a globe. So maybe it's easier to use polar coordinates for anything that is rotating around Earth, or anything that is circular in nature, that has a circular path. Does that make sense, guys? Okay. All right. Yay. I think we're winning, guys. Don't worry, miss. I recorded it, and we'll catch you up really quick after we're done anyways. It's pretty easy to catch up, so you'll see. All right. You guys ready? So when it says here, what's the difference between rectangular coordinates and polar coordinates? They're the same. It's just used for different situations. So I'm going to, different use. I'm going to say polar coordinates are better for, and I'm going to put anything in quotes, anything moving in a hyperbolic fashion. It just depends. You can go back and forth on if something's moving kind of hyperbolic, or you see kind of a curvature, nice circular, maybe it's better to do polar. You know what I mean? What's up? Like hyperbolas, ovals, circles. You guys have done hyperbolas before, right? Other than parabolas? Okay. All right, here we go, guys. Ready? So what are the 4 major formulas? X squared plus y squared equals r squared. What else did we say? We said that theta equals arctan of y over x. We said that x was equal to r cosine theta. We said that y was equal to r sine theta. Don't be a robot. Where did all these come from? Look, we just derived them here, guys. So they came from that. This is actually the last topic of Unit 3, guys, and we're done. Yay! What's up?
The radius is just
the distance from the origin to...
Yeah.
Yep.
Yeah. Just the same thing, just different letter?
Yeah. All right, so let's see. We're going to practice. These are all in polar form. How do they look in rectangular? What's up, Lopez? Check it out. So check it out. It says 4 comma pi over 2. So here's my quadrant, 1 and 2. I'm exaggerating it. Pi over 2 is the positive y-axis, yes or no? So here it is. That's pi over 2 right there. And then this is my radius. So I'm going to go from the origin. I'm going to go up 4. Boom. So there it is. That point is 4 comma pi over 2. Use your intuition. What does your intuition tell you about that point in rectangular form, in xy form? What's your x value? 0. What's your y value? There it is. See? We didn't use any formulas. Child, I want to use my formulas. Okay, if you want to use your formulas, look, check it out. If you want to use your formulas, guys, you could have said x equals 4 times cosine of pi over 2. I want to use my formulas, child. 4 times sine of pi over 2. Well, cosine of pi over 2 is 0. 0 times 4 is 0. And sine of pi over 2 is 1. 1 times 4 is 4. OMG, look, 0, 4. Now, don't be a robot. Remember, we derived them, right? So you guys know where it's coming from. All right, so here, what are we going to do first? Remember what we said? We look at the angle first. I know it's kind of a little bit counterintuitive how you guys were raised. You guys were raised like do X and then Y. So what are we doing first? The pi. So pi would have put us in the negative x-axis. But look what happens with the r. Is the r negative? So we're going to go in reverse. So now I'm in the positive x-axis. So I'm like right there. So that right there is negative 3, 0 in polar. That's in polar. Negative 3 pi. Sorry. Negative 3 pi. That is not negative 3, 0. Negative 3, 0 would have been the other one. But in a rectangular grid, what point is that in x, y? Your x value is 3 and your y value is 0. Yeah. It's just the distance from the x-axis to there. All right. I think I corrected what I said. Initially, I said negative 3, 0. 0, negative 3 would have been the negative x-axis. This is correct, negative 3 pi. Pi and then negative 3.
So if the radius is negative, it's just whatever the opposite, like just the sign.
No, you reverse from the origin. So instead of going
To the left.
Yeah. All right. Letter C, 5 pi over 6. What quadrant is that in? Second. And then you do an R of 16. So here it is. Here's my R of 16. This is just a visual, guys, for you guys. That point right there, that's 16 comma 5 pi over 6. R theta. You don't have to put the radius. You can just put the point. What is that x, y? Obviously, the x is negative. So here it is, the x coordinate. I'll take my 16. I write cosine of 5 pi over 6. So let's see what that is. Do you guys remember what cosine of 5 pi over 6 is?
Negative square root of 3 over 2.
Yes. 2 goes into 16 8 times. So negative 8 square root of 3. That's your x coordinate. The y coordinate. 16 sine of 5 pi over 6. So 16 times a half. What's half of 16? There it is. So that coordinate there in rectangular coordinate or Cartesian coordinate is negative 8 square root of 3 comma 8. And yeah, that makes sense. The x is negative and the y is positive. Because in quadrant 2, that's how it works. We still okay? Okay, here we go. I'm going to do this one in black. So here's my grid. And let's see, negative, negative. Okay, I like it. I love it.
I love it.
You don't love it?
No, I love it.
Oh, you love it. All right. Negative pi over 4. What quadrant is that? 4. But notice that r is negative. So it's going to put you in what quadrant? 2. Yeah, because here. Okay, this dashed line is not that line. I'm just showing the angle. That right there is negative pi over 4, that angle. And then you're going in reverse, so it's going to put you over here. There it is. So that point right there is negative square root of 2, comma, negative pi over 4. Chubb, I want my x and y coordinate. Okay, I'm going to come over here. X equals negative square root of 2 times cosine of negative pi over 4. How do I do that, Chubb? From the unit circle, negative square root of 2, cosine of negative pi over 4 is square root of 2 over 2. Square root of 2 times square root of 2 is 2, but I have a negative in the front, so that's negative 2, divided by 2, so I get negative 1. See? The y value. Y equals negative square root of 2 times sine of negative pi over 4, so that's going to be a negative square root of 2 over 2. Negative times a negative is so 1. So what's that point? That point is negative 1, 1. You could use a calculator to help, but I prefer that you don't. But you could always do this in case you're like, Chubb, I have no idea what you're doing. You could always do, let's see, what was it? Negative square root of 2 cosine negative pi over 4. And look, you're going to get your negative value, negative 1, and negative square root of 2. Oh, I didn't put negative. Second, insert negative. Sine negative pi over 4. Look, see? I don't want you to use. I mean, I prefer something like this for you to just. You know what I mean?
Yeah.
What type of bag are you opening?
Bag chips. But
Fried
I'm
chips.
scared that it's too
Oh, you're good, miss. What's up?
So, okay, I just want to make sure I got this right. If we were to land up in quadrant 3, and then we have to and then the radius is reversed, we would be in quadrant 4.
Yes. If your angle's in quadrant 3, but your radius is negative, you're in quadrant 1. No, I'm okay. Thank you, though. I don't like to get, you know what I mean? So, but thanks.
Well, so you know how we went to quadrant 2, and then because it's negative, went to quadrant 1, right?
No, if we're in quadrant 2 and it's negative, you're going to be in quadrant 4.
And how come in number 2 we were in quadrant 1?
In Roman numeral 2, we were not in any quadrant. We were in the axis.
Okay.
We were on the negative x-axis, and then that negative put me to the positive x-axis.
Oh, okay. So from the axis, it just flips,
Yeah.
and then it's just the opposite.
Yeah. You know what I mean?
Yes.
Okay. All right. Yes.
So technically, we should be solving before we're able to graph it because that would change what quadrant it is.
Yes. I think you missed it, but it's not a big deal. I told these guys that always do instead of doing x comma y how you do in Cartesian, to look at the angle first. Do the angle and then do the radius. Because if you do the radius and then you might mess up. So do the angle first and then do the arc. I have seen some textbooks. I don't know if it's because the professor was different or whatnot. I have seen some textbooks that reverse this, that go theta comma r. Almost every textbook that I've seen is r comma theta, and every now and then I'll pick a random textbook from a random university, and their professor, for whatever reason, he teaches his own class, he writes his own book, and here's the book we're going to use. We're going to use my book, and he reverses it. Maybe he does it because of that, and he knows that's what he tells his kids. But most textbooks, if you do a Google, I think most authors would say r theta. Every now and then you'll find a university article that has it reversed. So don't come in here, Chop, you told me wrong. This one says, relax. Almost every textbook, almost every standardized exam does r theta. But if you see something that's theta r, don't freak out. That just means someone just decided to write it that way. So yeah. Okay. Are we cool? All right. So these are all rectangular. The 1, 0, there's a reason that I put this one in there. It's not it's kind of cool, kind of not. So here's 1, 0. There's rectangular. And it says it wants two different sets. Look, fine. Two different sets of polar coordinates. Okay. R theta. So my angle, if you haven't moved, that's a positive x-axis. I could say that's 0. See? And then my radius is 1. OMG, it's the same coordinate in radian and polar. And polar and rectangular. Man, I said the same thing. You could also do one full revolution and then do an R of 1. You could have also, I know it's at 2, but I'm going to put 3 here. I could have also gone to pi and then make R negative. And all three of those are the same. Do you guys see that? Yeah, some textbooks will say 2 pi plus 2 pi n or 0 plus 2 pi n. That's because every time where n is an integer, every time you do a revolution, you're still in the same location. All right, check out the next one. Chub, I don't know what this is in radians. Okay, what does your intuition tell you? What does your intuition tell you about that angle there? No, not pi over 3. There's a 4 on the bottom. Yeah. 3 pi over 4 because it cuts quadrant 2 in half, that angle. Or because notice the magnitudes of the x and y coordinate are the same. So there's a lot of little different hints. Chop, how would I do that without a calculator? I don't know. Okay, guys, a hack. Look. The calculator is dumb, by the way. It does not know that you're in quadrant 2. This is why I told you to check quadrant. Let's see what 3 pi over 4 is. So let's just talk. 3 pi over 4 is this in decimal. So if I were to go arctan, and it was 3 divided by negative 3. 3 or y divided by x. Look, the calculator is dumb. So how do I get to this answer? Well, this is the right answer, but if you were in quadrant 4, if I want to go to quadrant 2, they're linear pairs. You just got to add pi. So if I go plus pi, see, you just got to know, if you know the concepts, you don't need formulas. Boom, plus pi. Look, same digits per digit. See? Okay, what was I trying to get to? Okay, that's what I was trying to say. How do I know that this is 3 pi over 4? Okay, guys, do it like this. If you don't know, here's a hack. Change it to degree mode because all of you guys seem to be super happy with degrees. So I'll put degrees. And then you just do the same thing. You just go arctan of this, you push enter, negative 4. Oh, I'm not in quadrant 4, I'm in quadrant 2. Let me add 180 plus 180, and then you get 135. And then like, oh, okay, 135 degrees. I know what that is in radians. 135 is 3 pi over 4, and then just write 3 pi over 4 if you're in radian mode. Does that make sense? Okay. So that didn't make sense? Okay, tell me where I lost you, because I don't know where I lost you.
No.
What do you mean?
Wait, why would we put it in our
to get our angle. Like,
angle?
yeah.
Oh,
Were you here for this part right here?
no.
Oh.
Well, yeah.
See?
Well, I wasn't here, but I don't know what's going on.
See this angle right here?
Yeah.
SOHCAHTOA. So tangent of y over x, tangent of theta is y over x. And if I want to get my angle by itself, you do the inverse. Theta equals arctan of y over x. And that gives you the angle. See? Yeah. Yeah. Yes. That's I wanna make sure that everyone's learning. Okay. How do we feel, guys? All right, look at letter C, or the Roman numeral 3 here. 0, negative 4. So here's my point. Toot.
We're just gonna find the folder.
Oh, I never found the polar? Dang. Okay. Polar coordinates. So I need my R. So let's do x squared plus y squared. Negative 3 squared, that's a 3, plus 3 squared equals r squared. 9 plus 9, that's 18. 18 equals r squared. Square root, square root. The square root of 18 is the same thing as square root of 9 times square root of 2. Excuse me. 9 times 2 is 18, right? What's the square root of 9? So r equals 3 square root of 2. And we already know that angle, so here it is. So here's my answers. Where do I write them? I write it right here. So 3 square root of 2, comma 3 pi over 4. And it wants two different ones. So let's see. What's another one? Negative pi over 4. And then I'm going to go in reverse. Negative 3 square root of 2. There it is. Yay or nay? I'm going to put this one in different colors. 0, negative 4 is down here. Okay, give it to me in polar. What is this angle? Yeah, 3 pi over 2. What's my radius? No, not negative 4. Negative 4 would take you to pi over 2. 4. That's one answer. What's another answer? You can say pi over 2, which is the positive y-axis, and then go in reverse, which is negative 4. See? Negative 1, 1. Don't worry, guys. We're almost done. Negative 1. Actually, this, you know what? This is actually kind of the same as this one. Kind of same, except for the radius. The radius is square root of 2. So I'm not going to worry about it. So I'm going to change this for next year. Change. They're similar to Roman numeral 2. So I don't want to do something if it's almost the same. All right, let's go to the next page. Use your intuition. Notice that it just says r equals 2. They don't give you any angle. So that means all the angles. So what shape will this look like? Yeah, just a circle with a radius of 2. Just a circle with a radius of 2. Oh, look at this one. I did that on purpose, negative 2. What about if it's negative 2? Did that change anything? No. It just, I mean, the only thing that changes is how they draw the circle in the calculator, but it's still 2. The radius is still 2. Yeah, because you start. Okay, I guess let's have a conversation. So check it out. I wasn't going to show you this just yet, but I'll show it to you now then. So you have a mode in your calculator called polar mode. So if you go to mode and you go to function, notice that it says polar on the third one there. So if I go to y equals, and let me change this to a 2. So I put a 2 in here. So this is going to draw the circle normal because you sweep from 0 to 2 pi. If I click on window, you see where it says theta min, theta max? That's 0. That's the starting. And the theta max is 6.28. That's 2 pi. See, this is 2 pi. If I put 2 pi in here, 2 pi, enter. See, that's 6.28. And the theta step, so watch. You're going to see this is pretty small. I did that on purpose, the 0.001. If I push graph, see, that's too slow. Let me change the speed. That's too slow. 0.01. Delete. Okay, now we'll be faster. Boom. It's still, oh, it's because I'm in degree mode. How come you guys didn't tell me I was in degree mode? That's why it's so slow. That's why it's so slow. Yeah, it's gonna go forever in degree mode. All right, now it's gonna go too fast. Window. 0.001. Okay, check it out. Look at. You start at 0. It's gonna go through the unit circle. Look, see, and then bam. But if I put a -2, so look, second insert negative. If I put a -2, it's not going to go that route. It's going to start there. It did the negative ones first. See? So, yeah. So the direction does play important, but right now we're rookies. This is our first rodeo, so we're okay. Cool, right? No, you're good. All right. Use your intuition. Does it say anything about R? So what do you feel if they just tell you theta is pi over 6? Well, how's that going to look? Just a line at pi over 6. So here's my grid. If R is positive, I'm going to color code this. If R is positive, you get this line. That's how you say R is positive. And if R is negative, you get this line. That's how you say negative. If they don't tell you any R, it's just a line. Where this angle right here, what angle, Chop? This angle. Where that angle is pi over 6. See, you guys are smart. You guys are using your intuition to put all these things together. That's how math is, guys. You just use logic. Cool, right? Are you not entertained? Okay. I'm entertained. Do you like my little emojis? I said, use a polar little side note. We may need to do no review of conics if you don't remember equation of a circle or ellipses. Do you guys remember equation of a circle or an ellipse? All right. I would thought that maybe you do from the SAT. The circumference was. All right, here we go. Here we go. Circumference is 2 pi r. That's how we get the radians. 1 revolution is 2 pi. From the 2 pi r. All right. Well, that's how you find circumference. That's not how you graph a circle. X minus h squared plus y minus k squared equals r squared. Does that look familiar to you? Maybe it looks like this. X minus h over r squared plus y minus k over r squared equals 1. They're both the same. You know, the common denominator is r squared, multiplied by r squared, you get the r squared on the right-hand side. Center at h comma k. Sometimes they say x naught and y naught. Sometimes you'll see it like x minus x naught squared plus y minus y naught squared equals r squared. Maybe that one's more popular in physics because they always say not for initial. Have we seen that before? No. Yeah. But at least we've seen something, you know? Okay. So here's what this problem wants us to do. We have an equation. We have the equation r equals 4 sine theta. And they want us to prove it's a circle. Well, if it's a circle, you will get this equation. So we need to figure out a way how we're going to go from 4 sine theta to this top line right here. How are we going to go from this to this? So use your intuition. Here's some formulas. Oh, what formulas? The formulas that we talked about earlier. Here's some formulas. Using your intuition, which one feels right to use it? All we have is r equals 4 sine theta. Which one of those 4 do you feel like we should probably use? Yeah, the first one. Is your intuition telling you to use the first one? Or no? Or is your intuition telling you like, IDK, I don't know. IDK? Okay.
My intuition's telling me 3 day weekend.
No. Your intuition is telling you like how to. Yeah, let's find this out. So we can't use the theta equals arctan y over x. We don't have any y's or x's yet. And then x equals r cosine and y equals r sine. Like, okay, we do have an r, but cosine and so like it doesn't like we have a sine, I guess. But how can we all mix this together? We do have an r, and look, the first one says x squared plus y squared. Oh, okay. So maybe if I use that first one, and then what you're probably saying to yourself is like, well, Chav, I don't have an r squared, but I can get an r squared if I multiply this by r, and whatever you do to one side, you do to the other. So now if I do that, I'll have this. R squared equals 4r sine theta. Now check it out. And I guess I'll put what I just used. Side note, x squared plus y squared equals r squared. And then I'm going to use this one. All right, check it out. In the process of doing that, you have an r sine theta right there. And look what r sine theta is. And r squared is x squared plus y squared. So now I'm going to have x squared plus y squared equals 4y. We're close now. Now we require algebra, so I'm kind of... Okay, I think we'll be fine. I'm going to move the 4y to the left. X squared plus y squared minus 4y plus a blank equals 0. Child, why'd you put a blank? Let me zoom out so I can see. All right, guys. This comes after you do like a lot of practice and where you got to figure stuff out, right? So in your head, when you're doing these types of problems, you should be saying to yourself this. I'm trying to get to here. I noticed that this is a binomial. Binomial is a fancy word for two terms. You have two terms in a parenthesis here with a square on it. Well, I don't have like any parenthesis with two terms on it. So I'm going to get a trinomial, and I'm going to turn it into a binomial with a square on it. And the only way to do that is by doing something called completing the square, which you did in algebra over and over again. Does that make sense? And don't worry, I'm going to fill you in on the little gaps if we have gaps. So this is why we don't want to be a robot, guys. So yeah, I can give you a handout, a worksheet, and follow these steps. But then we're like, okay, after I'm done with it, like, don't be a robot. See, if you do this, you practice all the time, make your brain think like, okay, how do I go from a trinomial to a binomial? You'll just know. You'll just know, oh yeah, I got to complete the square. All right, so check it out. Take this number. There's a 1 in front of that y squared, so that's perfect. That's good. That's good. Take that number. This is like doing that b over 2a. Take that 4 and divide by 2. What's 4 divided by 2? Or negative 4 divided by 2? What is it? Negative 2. And that's what they meant. And now I'm going to square it. What's negative 2 squared? Negative 2 squared? Negative 2 times negative 2? 4. I'm going to put plus 4 right here. Whatever you do to one side, you do to the other for balance. For balance. Complete the square. Okay, Chop, I don't understand what you're doing. I am totally lost. Okay, these three terms, I'm going to explain everything to you right now, and you will get it. That is just y minus 2 with a square on it. Side note. See, this is why we did it. Y minus 2 with a square on it means y minus 2 times y minus 2. And then look, y times y squared. Y times negative 2, minus 2y. Negative 2 times y, another minus 2y. And 2 times negative 2 plus 4. Y squared minus 4y plus 4. OMG, that is that. See? So y squared minus 4y plus 4 just turns into y minus 2 with a square on it. Do you guys see that? So, that's... Now look, Chop, I don't understand why I had to do that. Well, look, now it looks like this. Well, almost. I haven't written the equal sign. Equals 0 plus 4 is 4. See? Now it looks like that. From there, you can tell me that the center... Oh, okay, I don't want you guys to think that that's center, so let me get it out of there. Center, your HK, is 0, 2. So it's just, see, that's the same thing as x minus 0 squared. And then the radius is 2. So how does that look? If I were to graph it, it probably looks something like this. 0, 2, and it goes up 2, down 2, left 2, right 2. I didn't do it perfect, guys, but there it is. And it shouldn't be crossing. It shouldn't be crossing the x-axis. It should be touching. There we go. Looks something like that. We are gonna practice graphing a whole bunch of polar. We're not ready yet. We're rookies. We first need to start by plotting. Don't forget about graphing if we can't plot. So first we're gonna start by doing that. Relax. Check it out. We have already a calculator here. Look what I could have done with this calculator. I could have just typed in 4 sine theta. The theta is where the t's at, or the x is at. And look, if I push graph, whoop, circle. If I make it initially, it comes out like this, guys. Standard. Look, it looks like an egg, but just square the window. Go zoom, and then push the one that says square on it. 5, and when you square the window, it looks like a circle. Cool, right? Look, we can even make this like a meteorite. Like maybe this rotating about like something. So watch. I'm gonna put a little, and we can see the tail. So watch. Look at this, guys. This is gonna be fun. But look. It's rotating around someone. It's going too fast. Let me slow it down. Let's slow it down to 0.01. 0.001. Okay, look, check it out. It's rotating around something. Oh, or maybe it's too slow now. Yeah, it might be a little too slow, but it's, you get the point. Yeah, well, it's rotating around the 0.02, right? Like, so. But look, it's in rotating. Like, you guys don't think that's cool? Yeah, look, that's really cool. Look, it's rotating, guys. Rotating about some center. Oh, I wonder where that center is. Okay, I'll stop. Stop, enter. Okay, here we go. Yeah, we're having fun. We're having fun. All right. So here we go. You guys are trying some of these points. Well, some of these points are going to be from Delta. Let's see how we're doing on time. We have a short day today. Okay. So let's do some of these, and then we'll get you guys started on Delta here. Plot each point given the polar coordinates and find the corresponding rectangular coordinates. Okay, so first you do the angle. Power 4 is in quadrant 1, and then square root of 2. So you're going to be in quadrant 1. Boom. If you want to do your visual, that's r equals square root of 2, and that angle is power 4. So there's that point, square root of 2, comma, power 4. Do they want rectangular? And find the corresponding rectangular coordinates. Yep. Okay. X is equal to square root of 2 times cosine of power 4, which is square root of 2 over 2. So you're going to get 1. Square root of 2 times square root of 2 is 2, and 2 divided by 2 is 1. Y is going to get, you're going to get the same thing. So that point is 1, comma 1. Cool? I put 1, 0 again. Next time I'll change this one out. 1, 0 is not special. It's right here. And it's also 1, 0 in rectangular coordinates. 0 power over 2. This one, I like this one. Power over 2 is this, but if you're at 0, that means you're at the origin. So it doesn't matter what angle you put. If your r is 0, you're going to be at the origin. You can put any angle. Trickster, huh? What's up? Oh, I thought I heard you say chop. Oh, ka-chow. Ka-chow. Chow sounded like chop to me. Okay. All right. Power over 4. That's quadrant 1. But the negative square root of 2 is going to put you in quadrant 3. Because you got to go backwards. So here's quadrant 1. Here's power over 4. So here's my visual. That's the power 4. But you're going to go backwards. So you're right there. Okay. What coordinate is that? X equals negative square root of 2 times cosine of power 4, which is square root of 2 over 2. You're going to get negative 1. And the same thing for y. You're going to get negative 1. So negative 1 comma negative 1. What do you guys think? Not bad? Okay. Should we do some of these? Let's do A and B, and then we'll just go right to the last page, and then we'll wait for this one for when we come back. So negative 1, 1. So negative 1, 1. Negative 1, 1, something like right there. So your intuition is telling you, because the magnitudes are the same, that's probably 3 pi over 4. And your r, so negative 1 squared plus 1 squared, and it's the square root of that. So your r is the square root of 2. So in polar, it says two different sets. I'm gonna write 2 or square root of 2, comma 3 pi over 4. And another one, I'm gonna go negative pi over 4 and negative square root of 2. What do you guys think? Okay. Last one, letter B. 1 comma negative square root of 3. So not to scale. And let's see, positive, negative. So I'm in quadrant 4. 1 square root of 3. So we're probably like right there. Okay. What angle is that? How do I figure that out? I can go like that. Chav, I don't know what angle that is. The only way you're going to get, let's see, so I'm going to go arctan of negative square root of 3, y divided by x. And the only way, don't worry, we're almost done, guys. The only way you get an angle that's negative square root of 3, we're almost done, is if you have a y coordinate that's negative square root of 3 over 2, and an x coordinate that's a positive 1/2. And that happens when theta is 5 pi over 3. Child, there's no way that I could have figured that out by myself. I'll show you a hack on how you can do it. Thank you, guys. Thank you, guys. Take it from one of these packs that's in the middle somewhere. All right. So look what you could have done, guys. You could have done a hack. You could have done this. Second quit. Let me put my mode in degree mode. Job, because this is, I think, something you guys can do. You can just go arctan of negative square root of 3. And then look, negative 60 degrees. So there it is, negative 60 degrees. That's the same thing as pi over 3. Well, negative 60 is pi over 3, or negative pi over 3. But you know what I mean. Negative 1/3 plus 2 pi. So negative 1/3 plus 2. Turn into a fraction. Math, fraction, enter. And there it is. Put a pi on the top. 5 pi over 3. Cool, right? All right. Okay, here's the answer, guys. The radius. Square root of 3 squared is 3. 1 squared is 1. 3 plus 1 is 4. Square root of 4 is? So here's my coordinates. 2 comma 5 pi over 3. Or you can also use that negative angle they gave us, right? Negative pi over 3, comma 2. Both of those are the same coordinate. Because negative pi over 3, go clockwise. And then 2. Ask me.
Wait, okay. Walk down the thing just really fast, like one more time. Just walk through everything.
Yeah, so I could either go. Can you see from where with it? That's 5 pi over 3. Or I could have gone pi over 3.
But then we just plugged it into we just plugged the
X, R cosine theta. Yeah, you can do that.
That's how I get the 2. We just did the
No, the 2 we got it from Pythagorean theorem.
that we plugged into
Yeah, I just said it out loud. 1 squared plus negative square root of 3 squared, which is 3 plus 1, which is 4, and the square root of that is 2. Cool or not cool? I know, guys, I know. Last one, we're not going to do this page, at least not yet. I mean, I think we could, but we're running out of time today. All right, look at this. All you're doing is plotting. You're just plotting 6 comma 11 pi over 6. What do I do first? Go to what first? And then I'm going to count 6 rings, or r equals 6. 11 pi over 6, boom. 1, 2, 3, 4, 5, 6. I felt like that song. 1, 2. La, 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 la. Oh, you guys don't know what I'm talking about?
I think I don't know.
Yeah. What's cooler than being cool? Ice cold. But he starts with a countdown. 1, 2. Okay, I'll stop. All right, guys. I don't know if you guys know that song because that's a really old one. Yeah, that's all you know. Okay. All right, guys, we're done. Just take care of delta. It's just plotting. You're not going to be doing like what this is, where you're finding equations of Cartesians just yet. And that's it. Hopefully, we learned a lot today, guys.